Hi, welcome back. This is Professor Ridge and today's lesson on 6.4 rational equations. So a rational equation is just basically any equation that contains rational expressions. So basically we're going to do the same technique we did before for clearing fractions. So you first find the LCD of all the fractions and then multiply both sides by the LCD, and that will clear all the fractions. So what's the LCD for 3y and 6? So that would be 6y. And what you're going to do is multiply both sides by the LCD. And just like we did in the last section, you're going to distribute that, and it's going to go to the top of any fraction. So we're going to get 2 times 6y over 3 minus 1 times 6y over y, 5 times 6y over 6. So normally I don't show this step, but okay, so 3 goes in 6 twice, so we get 4y. Y's cancel, so we get 6. 6's cancel, so you get 5y. And now this is just a regular old linear equation, so just solve it like normal. Okay, if you got a different equation, you just use whatever the appropriate technique is for the resulting equation. So your first step is you just clear the fractions, and then depending on what kind of equation you get, you solve that using the appropriate technique for that type of equation. So here we get y is 6, negative 6, sorry. And then if we check it, if you want, 2 divided by 3 minus 1 over negative 6, 5 over 6. So what you do is, if you just punch that in your calculator, you can see you get 5, 6, but if you want to do it by hand, get common denominators. Minus minus becomes plus, and obviously that's 5, 6. So there you go. Okay, let's try a little bit harder one. Again, I'm going to multiply the top and both sides by the LCD. So let's see, we got 2n plus 10, which is 2 times n plus 5. 4, which is just 2 times 2, and then n plus 5. So our LCD is going to be 4 n plus 5. So I'm going to multiply each fraction, or each term, so basically I'm going to distribute it with 4n plus 5. Okay, so I'm going to do the canceling. 2 goes into 4 twice, so that's 6. 4's cancel. I'm going to go ahead and distribute that. 5n plus 25. And that's 28. Now that's the linear equation again, so just solve it. So we're going to combine like terms. Subtract 31. So 28 minus 31 is negative 3. Then we're going to divide by 5, and you get negative 3/5. Then we're going to check 2 over 2, negative 3/5, plus 10, plus 5/4. Does that equal 7 over negative 3/5 plus 5? And let's see here. We get 2 over negative 6/5 plus 50/5, which would be 4 44/5. Flip it over, so that'd be 10/44 plus 55/44, 65/44, and then this one would be 7 over 22/5. Flip it over so you get 35 20-seconds. Ooh, that's not equal. Let me pause it here and see if I can figure out what I did wrong. Oh, it'll help to use the original problem. That should have been a 3. So that should be 3. So this would be 15/44, which will get me 70/44, which reduces to 35 20-seconds. So it checks out. Okay, good. So that was almost harder doing the check than actually the problem. Normally I would just punch it in a calculator and check it that way. So anyway, all right, let's try another one. Okay, so the LCD would be x minus 4, so we're going to multiply both sides by x minus 4. What happens is the x minus 4's cancel and you just get the numerators. And then you solve that. So x equals 4. Now, you got to keep in mind what the domain of this function would be. You know, if x equals 4 and you plug it back into it and you do the check, notice what happens. You get 4 minus 2 over 4 minus 4. It's true that these are equal, but the problem is 2 divided by 0, this is undefined. So that means you're not allowed to use it to begin with. So you have to throw this out and say there's no solution. So you're not allowed to use anything that would make the denominator equal to 0. So remember, our domain is x cannot equal 4. So if you get 4 as your solution, you got to throw it out. So if I got anything else, it would have been fine. But you're not allowed to use 4 to begin with. So since that's your answer, to make it equal, you got to throw it out because you're not allowed to use it. So no solution. Okay, so let's try this one. I'm going to factor the denominator. So we got factor 6, that's minus 3, minus 3. Factors 9 to add to 6. 3 comes out of this one, x minus 3. 2 comes out of this one, x minus 3. Okay, so the LCD would be 2 times 3, which is 6, x minus 3 squared. So that's what I'm going to multiply everything by. So I'm going to get 3 times 6 times x minus 3 minus 3. And again, normally I wouldn't write this step, just showing you for your notes. So x minus 2 times 6 times x minus 3 times x minus 3 over 3 x minus 3 equals x times 6 times x minus 3 over 2 x minus 3. So cancel and then multiply out what's left over. Cancel. 3 goes in 6 twice. So we got 2x minus 2 x minus 3. 2 goes in 6 3 times. So I got 3x x minus 3. Okay, multiply everything out. Combine like terms. So that's going to be, here I'm going to skip a little bit of work, just so 2x squared minus 3x minus 2x, that's minus 5x, times the 2 is minus 10x. Then 2 times 3 is 6, positive 6, times the 2 out in front, that's 12. Then I'm going to distribute the 3x over here. Okay. It's a quadratic equation. Let's get all the x squares. Let's combine like terms first. 2x squared, 10x plus 30. Okay, let's get it equal to 0. So I'm going to move everything, well, it doesn't matter. I'm going to move, I'm going to subtract 3x squared, add 9x. So I got negative x squared minus x plus 30 equals 0. Factor out the negative 1. I'm going to factor factors of 30 to subtract to 1. 5 and 6. And set each factor equal to 0. So that one gives me nothing. So add 5 to both sides, so x equals 5, subtract 6. And then we just got to double check to make sure that none of these make the original statement undefined. So remember, so note, what's x not allowed to be? X is not allowed to be in the original problem. Only 3. 3 is the only thing that's no good. Everything else is fine. So neither of them need to be thrown out, so they both work. You can check them if you want. But the thing that you got to check for is make sure that neither of these make the original equation undefined. So 3 is the only one that doesn't work, so 5, negative 6 are both okay. Okay, so that concludes your lesson for 6.4. Go to my math lab and complete your exercises there, and I'll see you next time.